Okay, so Mr. Rob's here, and we're on the part 2 of the unit circle. It says, using unit circle and special triangles, find the value of the following. Sine of 120, cosine of 120, tangent 330. So in order to do this, we need our special triangles. So I'm going to do a quick sketch over here. Here's my special triangle. One of them, here's my 60 degrees, my 1, my 1/2, and my root 3 over 2, and this is 30. So now that I have my special triangle for 30, 60, I also know I have the other one, which I may not need this time. I know this is 45 and 45, and this is 1 square root 2 over 2 and square root 2 over 2. Alright, so going over the sine of 120. The first step in doing these is we want to draw. Okay, and so when I draw it, I know I have my scenario, my unit circle is here, and I know that 120 degrees goes from here roughly to this position here. Okay, and so this is 120 degrees. Okay, from my 120 degrees, the next thing I want to do, the second scenario, is I want to find the reference angle. Okay, and so if this is 120, I know my reference angles here is always to the x-axis. Here is 60. All right, and so I got my reference angle. And now I'm going to do sine. The sine 120 is equal to this height here, which is the opposite of 60 degrees. So I'm going to find the value of sine of 60. Okay, so then I'm going to go find the value. So sine of 60 I know is root 3 over 2 over 1. So I know this value is square root 3 over 2. This height here is root 3 over 2. Cosine would be this one here, which is going to be 1/2. And so I know sine of 120 is root 3 over 2. But the fourth thing I have to consider is if it is positive or negative. Because I know this is a coordinate point here, and I know the coordinate point here is x and y. Sine is the y and is going up. It is square root 3 over 2. But if I was going to do the cosine, this value here is 1/2. The length is 1/2, but when I go as a coordinate, it is negative in this one. So this is negative 1/2. And so when I do cosine, I draw it out. It's the same angle, 120. My reference angle is 60 again, because I'm drawing the triangle to the x-axis, always to the x-axis. Get your reference angle, which is 60. Find the value of cosine of 60, which is 1/2, which is this distance here. And then I think about positive and negative. It's an x value, it's going this direction, so it is negative. Okay, and so that's how we can use our unit circle and our special triangles to help us out. But we have to go through these 3 steps. If I take you through the 3 steps, or these 4 steps, I'm confident you can follow me along, but you have to come up with these steps on your own. And you have to do them so quickly that it's automatic. So this requires a lot of practice. So now when I do tangent of 330, first step is I'm going to draw it out. Okay, I know it is here. I draw it out and I draw my triangle to the x-axis, always to the x-axis, because then I get the correct reference angle, which in this case is going to be 30, because that's 330 here. So I've drawn out, I've got my reference angle, and now I need to find the value of tangent of 30 degrees. Well, tangent 30 is 1/2 over square root 3 over 2. Well, that's 1/2 over square root 3 over 2. If I do some quick calculations here, it's 1/2 times multiplied by the reciprocal, which cancels here, which I get 1 over root 3. I'm not allowed to have a root 3 in the bottom, so it's pretty messy. I multiply by root 3 over root 3, which is now root 3 over 3. And so the tangent of 330 is root 3 over 3. And then I have to think about positive and negative. Well, I know tangent is opposite. This is a negative over adjacent, which is a positive. Or I can think about sine over cosine. A negative and a positive makes a negative. So tangent 330 is negative root 3 over 3. And so you have to, this last one here in the end, people often forget to think about positives and negatives. All right, so let's have a quick conversation about the signs of the quadrant. I know if my angle is in here, okay, my x value here is positive, and my y value here is also positive. And so my sine is positive, cosine is positive, and tangent is positive. So they are all are positive. If I go into the second quadrant, right, this is the first quadrant here, this is the first quadrant. If I go into the second quadrant, which is over here, I know that my x value is negative and my y value is positive. So it's like a negative and a positive. So this is cosine. So cosine is negative, sine is positive. So negative is cosine. Tangent will be sine over cosine. Tangent is negative. And the positive one is sine. Okay? And so sine is positive. All right, if I go to the third quadrant, I know this is the second quadrant. Let's go to the third quadrant now. If I go to the third quadrant, I'm over here. I know that this is negative and this is negative. So it's a negative, comma, negative. So I know cosine is negative, sine is negative, but tangent is sine over cosine. It is positive. Tangent is positive. Okay, and so tangent's positive. And then the last one we'll do is in the fourth quadrant. Right, when I go to the fourth quadrant here, I have my angle here, make my triangle to the x-axis. This is positive. This is negative. So this is a positive, comma, negative. And so positive is cosine, negative is sine, and tangent is positive over negative, so it is a negative tangent. And so cosine here is positive. And so what we often think about when we do these is I think about these letters here for a quick shortcut. Back when I was in school, my teacher called this the cast rule. The cast rule. Cosine is positive. All were positive. Sine was positive. Cosine was positive. Another thing I've been shown in the past is all students take calculus. Is another way that we could remember it. But this is just a mnemonic device to remember which ones are positive. You can always go back to the first principles and thinking about positive and negatives, but you want to do this quickly.